Hi everyone, so my name is Miss Taylor. I teach at the Montgomery School District. I teach actually at the middle school and I usually teach 7th graders, but I actually started teaching in 6th grade. So I'm excited to get started today. We're going to be working with algebraic expressions, variables, constants. There's so much. I know these are huge vocab words, so it's kind of like, ooh, really lady? Like, can we pause a second? Don't worry. You've got this. We've got this. We're going to work through it, all right? Trust me, in a color code, it's going to be a good time. And if it's not, I don't know what I can tell you. I have been in New Jersey all my life. Jersey born, Jersey bred. I just got married. 2-3 months ago, actually before the quarantine. So it's been very interesting. But you know what? It's really helped me to reflect back on teaching and just helping everyone out there. So let's get started.
Let's take a look at what I've got behind me. If I were to ask you how many triangles you see here, you'd tell me. You got it, 1. And then how many triangles do you see here? Again, 3. So what if I were to ask you how many you have in total, like in all? You got it, 4. So there's 4 triangles. So when we're combining like terms, we're basically combining little groups of the same identity, right? Like if I had 1 triangle, 3 triangles, and I have 4 triangles. It's very similar when we replace this with variables. I know, big words, but try and remember the vocab words. We have Alright, let's try these. How many x's do I have here? We've got 1 x, and I'm going to write it exactly like that with a label. Now what about here? We have 4 x's. So now if I were to combine these, and what I mean by that is we are going to add them, how many x's would I have in total? You got it, 5. So you actually just combined like terms. So how many x's are here? Go ahead and answer. That's right, we've got 5 x's. Okay, what about over here? We have 1 x. So figure out, how many x's are there altogether? God, there's 6 x's. So there's 6 x's. Now, these look a little funny because I didn't put the little S like I did here, right? I put the S to represent triangles. But over here, I just put X because that's how you would represent it when we're working with addition or subtraction. So now let's take a look at these. We have my name, it's Taylor time, Miss Taylor. And then we have another name, Tailor. Now you probably were thinking I spell my last name like this, but I actually don't. I spell it with an I, whereas this one's spelled with a Y. So those small details are going to make the biggest difference when combining like terms. When we combine these like terms, we want to make sure we pay attention to all those little details. So little details might include exponents, they might include a different variable, they might be a bunch of different variables together, right? When we take a look at this, we want to look at everything that's multiplied. So right now I have the variable t, variable a, variable I, variable l, variable o, and variable r that are being multiplied to each other. Let's not worry about the numbers and the constants and the coefficients just yet. Let's just focus on the variables. We have Tailor spelled out with this term. Then I have this term, and this is Taylor. So you're going to help me out because I have a bunch of cards here, and we have to figure out what group they go in based on the small details. This is how we would combine like terms so that we can figure out what the total amount is, right? Like how many people do I have in a group here? How many people do I have in a group here? I like to think of like terms as people or objects or things because when we think about it and we say, oh, put all the squares together, you can literally pick up all the squares and put them together in one group, whereas all the circles might be in another group. or if I ask you to color code it. Ooh, okay, we're gonna have pinks here, we're gonna have reds there, we're gonna have gray here, right? We group it. So same thing with all of these small details. I'm gonna hold up the sign and you're gonna say left or right. I know on your TV it's left or right. For me, it's the opposite. So again, left for Tailor with an I, or right for Tailor with a Y. And shout it out because, you know, it's going to be really hard for me to hear you a little bit. I know I'm 100 years old. Just kidding. But make sure you're shouting it out so I can hear it, all right? And we can put it in the right spot. All right, let's see. Oh, okay. We're going to the right. Okay? You got it. To the left. Left. Good, and we're going to keep going until all of these cards finish. Over. Okay. To the left. How many Tailors with an I do I have here right now? I love how you had said there are 3 Tailors, right? You just didn't say 3, but there are 3 Tailors because those numbers are going to be super important. Remember, those are our coefficients. All right? To the right. Ooh, the tape got stuck. This happens. Okay, we'll just get another piece of tape. What about this one? All right, we've got a couple more. Is that hard to see? It's in yellow. Over here? Oh, okay, I'll put it here. All right, got it. It's this way. Okay, so you gotta put it to the left. Ooh, sorry. My left, your right. I know it gets confusing when we're on opposite sides. But this one, is that right? Okay. And last one. Here? Okay. Now, let's count up how many Tailors with an I that we have and Tailors with a Y. So this way we can kind of put our like terms together. All right, I'm going to use blue for Tailor with an I. How many Tailors with an I do we have? Count out loud. You got it. So when we write this, I know it's a lot of variables put together and it looks a little silly, but just bear with me, all right? We've got 5 Tailors. Okay, now I'm going to use purple for Tailor with a Y. How many Tailor with the Ys do we have? Awesome. And we have 3 Tailors with a Y. Now, if we represented this just with simpler variables and simpler terms, it would kind of look like this. So Tailor with an I is going to be X. I would have X. And then, in the same group of people, because we're all traveling together, right? Oh, marker's falling. At least I'm not throwing them at you. We have 3. And we're going to represent Tailor with the Y with a Y. So now when we're combining like terms, I just took all of this and put it into an expression. And what's the difference between an expression and an equation? I'm going to give you guys time to think. Try and tell a trusted adult near you or a friend, someone, anyone. Good. I heard someone whisper and they're like, I'm not sure, but equation means there's an equal sign. Do we see an equal sign here? No. What we just did with the Tailor versus Tailor example, we took all of the ones that look alike, and it kind of helps right now because it is color coded, and you know, you might be using a pencil at home or a pen and it might all look the same color. That's okay. We're going to go over tricks that you can use if in case you don't have markers or colored pencils, or, maybe you're taking a quiz and you're like, I only have a pencil. It's going to be in gray. Do I make it darker gray and lighter gray? We'll get to that in a bit, okay? So when we do this, we have 5 x's. So we added them all up because every single one was addition. We got 5x. Now, for the rest of the expression, we added them all up because it literally shows us all addition. Now, do we get a positive 3y or a negative 3y? Because that's what the symbol is going to be in the middle, right? These positives and negatives that we have in our like terms also act like addition and subtraction in our expressions. So we kind of have to get our minds used to that and thinking about addition and subtraction is the same as positives and negatives with algebraic expressions when we are simplifying. Good, I heard someone shout it out, so it's positive. That means our final answer is this. This is simplified. We get 5x plus 3y, or 5 Tailors and 3 Tailors, right?
So what is a variable? Now, some of you have heard the definition of a variable before or know what it looks like. And let's reveal the answer. Let's get rid of these smiley faces. A variable is a symbol, usually represented by a letter that stands for a number, right? So go ahead and copy that down. I'll give you some time. We're good? Okay, so let's try constant. Constant is when you have a number and it stays the same, right? It's consistent. It stays the constant. Constants, if you notice, don't have any variables, right? There's no letters attached to them. They're just a number. All right, big word coming up. We've got algebraic expression. Now, some of you are probably like, what? Hold on, wait. I didn't sign up for this. It's okay. We're going to go through it step by step. We're going to be able to simplify algebraic expressions. And what I mean by simplify is solve and add and subtract them. Let's get the definition, though, before we get there. So, a mathematical phrase that contains at least one variable. Okay, so I just need one variable, and it's an algebraic expression. Cool. One thing to notice, and write down actually on the side, there's no equal signs. There's none of this. Expressions do not have any equal signs. And then the last word we're going to focus on is evaluate. That actually just means to solve. Big fancy word for solve. I know, mathematicians make it so much harder. But it's okay. You'll be a mathematician in no time. Example number 1 says n plus 5. Ask yourself, is this an algebraic expression? Well, yes, it is. Let's bring that smiley face back for a second. Now, it's asking, what is the variable? Well, if I remember my definitions, a variable is usually a symbol or what? Oh, I heard someone say it. Yes, you're right. I heard it. A variable can be a symbol or a letter that represents a number. And in this case, that letter is n. Okay, what is the constant? Is there a constant? Is something there that would never change? You're right. That 5, right? That positive 5 is never going to change. So 5 in this case is my constant. Okay, I'm going to give you some time to try example number 2 based on my answer for example number 1. Go ahead. I see some of you quickly rushing to write it down. Some of you are, really using that pencil and tapping it on your head going, what is this? So, is it an algebraic expression? Absolutely right, it is. What is the variable? You're right, it's t. And I try my T's a little curvy because sometimes when people go like this, it's like, oh, is that an addition sign? And you're like, no. So it might help you to draw it a little bit curvy. It might be a little hard, but that's okay. Practice a little bit and you'll get there. So what's the constant? Because I see two numbers. Oh, I see you nudging your friend over there and you're kind of like, it's the one without the variable. You are totally right. It is 13. So once we learned what these vocab words means, like variable, algebraic expression, constant, we were able to evaluate and analyze, right? So let's take this a little bit further. Let's get some couple of other vocab words. Got your pencils and pens or papers ready? All right, the first one. When addition or subtraction signs separate an algebraic expression into parts, right? We have different parts of an algebraic expression. It's called a term. I'm just letting you guys write a little bit. All right. Number 2, the numerical factor of a term that contains a variable. So it's that number part. Even though the whole thing has a variable in it, it's that number part. It is a coefficient. That word, that beginning part of the word, that prefix, co, is kind of like, hey, nudge, nudge, buddy, I'm with you here. Right? And they create a term. Now, the coefficient of a single variable, right? Like, let's say just I have the variable x. Okay, no numbers attached to x, but there's actually a number there hiding. It's kind of like their imaginary friend, right? It's 1, because 1 times x will still just give you x. Now, number 4, a term without a variable. That means no variable at all. Oh, we already learned this. I know. You got it. It's a constant, right? We brought that vocab back because we want to remember all these pieces. And then terms that contain the same variables, right? That's kind of like taking back to my last name, right? My brother, so-and-so Tailor, is related to that and that Tailor, but they're both Tailor. So they're the same variables, right? The same last name. I like referring to variables as the same last name. They can go into the same car. And when you combine it, they're all called like terms. So with addition. So let's take a look at the word term. It is a variable, number, product, and remember, product is the answer to multiplication, or quotient. Remember, quotient is the answer to division of numbers and variables. Now, I'm taking my time to write this because I want to make sure that if I look back at my notes, I can read my vocab words and realize what they are. These are also, I can read that, hey, you know what? These are separated by addition and subtraction. So let's write that down. They're also separated by addition or subtraction. Squeeze that in there. I know. It's okay. So let's take a look at these examples. This is a term because there's multiplication. This is a term, there's division, multiplication, and then just a constant, right? That word constant is another one that we're going to look back at. Constant is a number with no variables. So just like a regular number, or counting numbers that we've actually, known since kindergarten. Let's look at some examples that are not terms. This is not a term because of this addition sign. Same thing here. This whole thing is not a term. That whole thing would actually be called an algebraic expression, right? And expressions have no equals signs. If it has an equal sign, it's an equation. So let's take a look at number 1. It says 9y squared plus 13y squared plus 3. How many terms are in this expression? Awesome, there's 3. What about the next one? That's kind of really long. I'm going to wait for someone to shout it out. Oh yeah, I'm letting you shout out. Shout it out. Yeah, you got it. Woohoo, let's write 6. What about the next one? 2. And number 4? 1. Awesome. So, we got a little grasp on terms. So let's take a look at like terms. Let's add that to our list. So they are terms, just like the words say, terms that contain, so that have the same, and I'm going to put this in capitals because I want to make sure I remember that, the same variable raised, if they have an exponent, raised to the same power. And I put an exclamation point because that's like super, super, super important. Those 2 words, same, and I'm highlighting them here, same. So it's kind of like when I explain my last name, right? My last name. I'm going into the car with people who have the same last name, even those small details, right? The small details for powers, they need to be the same. Like for me, I need an I in my last name, whereas another Taylor might have a Y in their last name, but that's not the same as mine. So you want to be careful there with all of those little details. So now let's take a look at like terms. Can we actually figure out the last name of this one? Does anybody notice? Ooh, you notice? Yeah? What is it? Yeah, that y squared. That's the last name. So anything else like negative 15y squared is going to be a like term because it has y squared. What happened to here? No, they don't have the same last name. You know why? There's no exponent here, but there is an exponent here. So this is like me saying 13x, because this is not the same last name as the other ones. So go ahead and try these on your own. I'm going to show you the answers. Go ahead and finish the like term examples and the not like term examples. So remember, your examples might be different from mine, and that's okay. The main thing that you want to focus on are these last names, right? What's similar about it? Those x's are all the same last name. XY is the same last name. X squared y is the same last name. Whereas these are all different. All of these are different. These last names are different, so there can't be like terms.
So remember how I said it doesn't matter if you don't have colored pencils or if you don't have markers and all of this stuff. It's okay. If you just have a pencil, we're going to start to work on different ways of using shapes, which is why Montgomery Soccer, I'm going to use shapes. I love referencing these as basketballs or beach balls or soccer balls, because it's kind of like rearranging things and moving it around. It's like imagining these terms each on its own soccer ball or beach ball, or honestly when you're using shapes in a square or triangle. We're going to assign those like terms either a shape or a color. So again, if you're using a pencil, you're going to want to stick with shapes. We don't want to shade anything in. We don't want to color anything in. If you're using colors, you might want to do both, because visually you'll be able to see the shape and you'll distinctively be able to identify the colors and be like, oh yeah, these go together. So I'm going to do both. Let's say all the ones with the last name X, meaning the variable X. Doesn't matter what the first name is, right? The last name, what we group it, is X. We're going to circle those. Now when we circle them, remember, we want to include the sign in front of it. That's part of its last name. It belongs to it. 3X. Am I circling this? Yes. Yeah, I know it's not a perfect circle, but it doesn't have to be, because I know it's a circle. What about positive 9y? See what I did there? In the expression, I know you read it as 3x plus 9y plus 2x. But when I look at the terms separately, this was 3x. This is positive 9y. Positive 9y, am I circling it? Why not? Oh, because the last name is not X, it's Y. Positive 2X. Am I circling that? Why do I need to circle it? It has a 2. You know what? You're great mathematicians. You're totally right. I should be looking at the last name, the variable, to tell me, is it the same exact as my initial grouping, the X that I started with? So I'm circling the positive 2X completely. Okay. Now, even though I'm switching colors and I know I'll visually be able to see it, you can use a square now. So what's another grouping I might want? I have X. For this specific one, I might want Y. So I have my positive 9y. So do you see how now this can literally show us which ones we need to combine and which ones we can't combine at all? 3x plus 2x, we get 5x. Now, I know some of you want to use the commutative property, right? And you can do that. You can totally rearrange it. Imagine thinking of these on flashcards or literally on beach balls. So, I put flashcards over them. I know we circled them, we color coded them, but I want to now visually, I want you guys to use your brains and think about how can I rearrange these in my mind. So I have 3x plus 9y plus 2x. I color coded it, right? We had these two circles and this one had a red square. So if I were to take these, and I'm imagining these all on a soccer ball, right? These are circles. So I can literally rearrange it and be like, okay, this can go next to here, and then I can take this term and put it at the end, because now I can actually combine them more easily when I look to simplify this. These two are the same color, or on your paper, they're the same shape. What is 3x plus 2x? Now remember, that's just like saying I have 3 x's here and 2 x's here. How many x's do I have in total? And I heard someone in the back shout it. Yes, you got it. I'm glad to know that you're awake. So, now what do we have left to do? We still have that yellow flashcard over there. We bring him down. So remember when we were talking about positives and negatives and how they are similar and we can read them as addition and subtraction in expressions. This is why when we bring this down right on its separate flashcard over here, separate flashcard, this is a positive 9. When I bring this down and attach it, all of a sudden I get 5x plus 9y, and I end up with my final answer. You know what I want you to do? I want you to try and answer it on your paper, because you guys are mathematicians. You know much more than me. Yeah, you do. Believe it. So let's go ahead. 3, 2, get your pencils ready. 1, go. okay. That's fine if you're done. I'm not done. Let me work, okay? I sometimes like to think my things through and make sure I'm doing the right thing because, you know, some of you like to rush, and that's totally okay because you could get to the right answer because you're like, you know what, I really know what I'm doing. While others realize, you know what, I need some time with this, and sometimes I'm shy about it because other people beat me to the answer. But that's okay. You're only versing me, and guess what? I'm still not done yet. And remember, you're only versing yourself because the more you practice this, the better you'll get at it. So let's keep going. So, did you get the same answer as me? Because I got ax plus 15y. Awesome.
So I'm going to introduce to you Miss Lachenaur. She's going to take us on our brain break so that we can refresh all this going on up here, slow ourselves down a little bit with the math, and, then we'll get back to it. Hopefully the math so far hasn't been too bad, and you know what? I'm learning a lot along as I go. I've learned that I need to talk a little bit slower, so we're working on that, right? We've all got things to work on. Okay? They're all yours, Miss Lachenaur.
Thanks, Miss Taylor. I'm Stephanie Lachenaur, and I work with Miss Taylor at Montgomery Upper Middle School, where I teach global leadership and character college and career readiness, which is a social emotional learning class where I practice mindfulness every day. I also work with Mindful Schools, where we work to bring mindfulness to teachers and help them to deliver it to their students. I'm so happy to be here with you today, and I was thinking about what mindfulness practice we might do. And I thought that you might enjoy doing one that my yoga club students and my students in my classroom love to do. It's their favorite game, and it's called Stop, Walk, Jump, Squat. So as we get started, I thought we would define mindfulness. So mindfulness means paying attention in the present moment on purpose with kindness and curiosity. So we'll come back to that definition at the end and see how we do. So wherever you are, I invite you to come stand up, shake it out a little bit. We're gonna get some blood flow and move around a little bit. So in our game, there are 4 rounds, and we're gonna start with round 1. In round 1, when I say walk, you're gonna walk around. When I say stop, you'll stop. When I say jump, you'll jump. When I say squat, you'll squat. When I say clap, clap. And when I say turn around, you'll turn around. All right, ready? Here we go. Walk, walk, stop, walk, jump, squat, walk, jump, squat, jump, turn around, clap, jump, squat, clap, jump, squat, turn around, walk, stop, jump, stop, walk, stop, turn around, clap, and stop. Great job, you guys. That was awesome. All right, so how did that feel for you? Was that easy or hard? All right, cool. So now we're gonna start with round 2. We're gonna make it a little more challenging for you. So when I say walk, you're gonna stop. When I say stop, you're gonna walk. Jump is still jump, and squat is squat. Turn around, and clap is still clap. Here we go. Walk, stop, stop, walk, jump, squat, jump, walk, stop, walk, jump, clap, turn around, stop, walk, jump, jump, squat, turn around, clap, stop, walk, stop, walk, stop, walk, stop, 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 walk. All right, that was tricky at the end, wasn't it? All right, round 3, here we go. When I say walk, you're gonna stop. When I say stop, you're gonna walk. When I say jump, you're gonna squat. When I say squat, you'll jump, turn around, still turn around. Clap is still clap. All right, here we go. Stop, walk, stop, walk, squat, jump, squat, turn around, clap, turn around, clap, squat, jump, stop, walk, turn around, clap, walk, walk, stop, clap, jump, squat, jump, squat, stop, stop, walk. All right, that was good. You guys are ready for round 4. All right, in round 4, when I say walk, you're gonna stop. When I say stop, you're gonna walk. When I say jump, you're gonna squat. When I say squat, you're gonna jump. When I say turn around, you guessed it, you're gonna clap. When I say clap, you're gonna turn around. All right, here we go. Stop, walk, jump, squat, clap, turn around, clap, squat, jump, walk, stop, walk, stop, stop, jump, squat, squat, clap, clap, turn around, jump, clap, walk, walk, stop, stop, walk. All right, nice job. Give yourselves a round of applause. That was awesome. So let's think about how that shows us a little bit about mindfulness. In round 1, were you able to think about other things as you were playing the game? Did it require a lot of focus? Probably not, right? Walk was easy. But when we got to round 4 and I asked you to switch everything, what happened when you started to think of other things? I know when I played the game, in the beginning, I was thinking about what I might do for a snack. If there was a game I wanted to play, my mind came up with a to-do list. But when round 4, I noticed when my mind started to wander, I would start getting some of those things wrong. So when we practice paying attention and we're in the present moment, we're able to participate and do what's happening with us right here and now. So thank you so much for practicing with us. I hope you had a really fun time. And now we're gonna go back to Miss Taylor to our awesome lesson. Take it away, Miss Taylor.
Thanks, Mrs. Lachenaur, for that. I had to tie up my hair. Whew, get the juices flowing, calm, collective, and ready to get started with some more math. So now let's take a look at these problems. You might be assigning circles and squares and triangles to them, and remember, I'm giving you different strategies. So now I'm going to use that note card method again with the different colors. But each color, like you can do it with your pencil, you can use a shape. Circles, squares, triangles, beach balls, soccer balls, right? Think about physically moving it around. So right now we have 4x plus 2 minus 10 plus 2x. This looks a little bit different than what we worked on before because now we have subtraction. But guess what? It works the same way. Right? We have our terms, coefficients, everything is still there. But now we're going to take a look at it to work on these. Okay, so you probably assigned these their own colors, right? We have minus 10, our plus 2, our positive 2x, and our 4x. So now we want to rearrange them so that we have our like terms together. And since mine are color coded, it's visually appealing, right? But as you listen to me, you know that all the like terms have the same last name, right? Plus 2x next to each other. And I'm going to put positive 2 and negative 10, or positive 2 minus 10, right? See how that addition and subtraction is interchangeable with positive and negative next to each other. This way, when I go to solve it, I know that I'm going to get 6x minus 8. Now remember, those integers over here, it's minus 8. So I'm going to grab a set of new flashcards just to write it down here. I have 6x minus 8. That is my final answer. So let's look at our next one. We have 6n minus 7n minus 4. Got a lot of subtraction in here. Plus 9n. Make sure if you have your circles around your 6n, negative 7n, positive 9n. And then you have your negative 4 or your minus 4 in as one term on its own. So it could be in a square, different color, just like I have it here. All right, let's rearrange it. Use the commutative property. Now I can combine like terms. Now some of you are kind of like, ooh, I can combine my like terms, but we have 3 terms. So take your time. Take the first 2 and combine them first. What is 6n minus 7n? You got it, negative 1n. And then bring what you didn't use down. Now, this could still technically be a circle, just like I used before, because those are like terms. Now we get 8n minus 4 as our final answer. So see how you take steps to simplify it further? Now you go ahead and try the next one. You should have gotten 3y plus 6. Now our final thing that we're going to work on today is the distributive property. Now you might be thinking, distributive. Doesn't that mean like to distribute? Yeah. So when we're distributing, we want to use multiplication, right? This guy out here is telling me, hey, you got to multiply me. And in order of operations, you want to remember that big thing called PEMDAS, right? Please excuse my dear Aunt Sally, because it stands for parentheses, exponents, multiplication, division. Those 2 are left to right. Addition and subtraction, again, from left to right. So let's take a look at this. Same thing, order of operations. If I look at my parentheses, they're not like terms, so I can't combine them. Well, I need to break those parentheses phrase, and this way I can simplify this. I want to distribute. Now, anybody notice what colors these are? Those of you that like art or know anything about primary colors, yes, these are the primary colors, and I color coded it this way so that when we go to answer these, it's all going to click, right, when we combine them and multiply them, just like if we're combining colors. So we are going to distribute. And when we distribute, we want to share with everyone, right? Everyone inside the parentheses. So first, we're going to distribute 4 to the 2x. So what is 4 times 2? 8, good. And you add that last name to it, right? 4 times 2x is 8x. So 4 times 2 is 8, and then you add the last name in there, 8x. So you get 4 times 2x is 8x. And yellow mixed with blue is green. So we get 8x from here. Now I'm going to multiply, right? I have to distribute my 4 to my y. Remember, it might help to draw these arrows. And again, if you can't color code it, it's okay. At least you're visually learning now. And then you can write it down with a pencil. You can use your arrows, you can use shapes, right? Use what you have. So now 4 times y is 4y. It's a positive 4y. And yellow times red, or yellow blended in with red, will give me orange. Now if I look at these like terms, can I take them any further? No, that's it. This is our answer. We don't go any further than that. So what I'm going to want you to do is take a look at the next one. We have 5 plus 2, parentheses, x minus 3. Now I color coded these because we want to focus on what we're distributing. And we're only distributing this positive 2 because that's what's being multiplied to the parentheses, right? When you don't see anything in the middle, it means multiplication. So we're going to distribute our positive 2 to our x, and we get positive 2x. Then we're going to distribute our positive to our negative 3. What's a positive times a negative? It's a negative, so we're going to get negative 6. Okay, I can't combine these, so I'm done. What? Oh, I forgot to bring my 5 down. Absolutely do that. Bring him down, because what do you notice now? Are we done? No, we can combine. We can combine these and simplify them further. So if I were to rearrange these, I can now combine 5 minus 6. What is 5 minus 6? Negative 1, you're right. And I have positive 2x, right? Because I have my terms. Do I have to write that positive in front of the 2x? No, you don't. Because in an expression, you would just get 2x minus 1. So I'm hoping these color coding methods are helping you, and we're going to practice a little bit further.
Go ahead. Don't rush. It's okay. It's not a competition. Remember your vocab words. How to combine, how to distribute. Those steps. And if you need to look back at your notes, go for it. Look back. If you want to check your work, go ahead and look at the screen.
So we are done with our lesson. Do you feel good? Do you feel overwhelmed? Think about it. Be present in the moment and acknowledge those feelings, right? If you're feeling overwhelmed, it's kind of like, what could I work on? What can I work on? Or am I appreciative that I could watch this and really learn and understand new, different strategies? I hope that my color coding strategies helped you and that you'll take them. Highlighters are your best friend, all right? Color coding and all of that stuff. And even if you just have a pencil, that's okay because we found ways around it, right? Use the resources that you have to your advantage. Now, hopefully the math wasn't too hard and that we really did practice and walk through and hone in on those skills. I want to say this was awesome, awesome opportunity. Hey family, aside from the lesson today, I want to see if you can figure out, there was a little game that I was kind of playing. I'm going to leave you with this question. How many different outfits did I have in this 1 hour lesson?